Okay, so I wrote the formulas that we just derived on this side, but now let's calculate the gradient and the Hessian of this one, as we're gonna follow Newton. Yeah? So the gradient with respect to W of the log loss, yeah, equals, I keep the minus, I keep the sum, and here I'm gonna use this formula. So it's yi in the front, and then the derivative of log alpha I is xj, but I still need to put the I, yeah? So it becomes xij times 1 minus alpha, okay? And then plus 1 minus yi, and here you have log 1. Yeah, so this becomes a negative, because of this one here, and this is then xij times alpha I. Okay, so basically I just put these guys in here, yeah, as well as here. Okay, so now we're gonna do some algebra. Equals the sum I is 1 to m with the minus here. We're gonna calculate this out, yi x ij, yeah, and then minus alpha yi xij, and here I do the same. So it is minus xij alpha I, and then plus yi times xij times alpha I. This is just algebra. Now we see that we can take these two out. These are the same. Yeah. So we're left with minus the sum of yi xij minus xij times alpha I. Yeah. So let's now take the x outside. So let's make xij, yeah, times here I'm left with yi, and here I'm left with minus alpha I, yeah, but that is equal to the sum of xij. Let me put this term first, yeah, of alpha I minus yi times xij. So this is the gradient with respect to this loss function. Okay, so that is the outcome. Okay, now what is this? This vector, this is a dot product. This is a dot product. And it's the dot product of this vector here with the jth column of the x vector. Remember here, so we have an x vector, xij, yeah, and that is so x 1 1 all the way to x1d. There's d features, and here you go down, there's m rows, because there's m sample, xmd, yeah? And xij is basically column j of that matrix. So that means that the gradient with respect to w of the log loss equals let's write it in a matrix form. So we have that the gradient of w of L equals L. We have alpha minus y, and we're gonna transpose this times x. Yeah? So we're gonna transpose this once again, which we can do, and it's just making from rows columns. So we're gonna transpose it one more time. And then we have that the gradient of this LW with respect to W equals, yeah, x transpose times alpha minus y. Sorry, I'll put vectors here. Alpha minus y. Yeah? And this is the formula that we're gonna work with. Yeah, so now we calculated the gradient of this cost or loss function.